In March 2025, the massive cyclone Alfred slams into Queensland and northern New South Wales, Australia. It began forming in the Coral Sea around February 20th, 2025, fueled by seawater temperatures above 26.5 degrees Celsius. After a slow 2-week journey across the ocean, Alfred hits land in the second week of March. So, what turns a calm ocean into a raging cyclone? Let's dive into science. Tropical cyclones are massive low-pressure storms with winds over 74 miles per hour. Called hurricanes in the Atlantic, typhoons in the Pacific, or simply cyclones in Australia, they form over warm tropical oceans and hit hard with rain and wind. Cyclones need 5 ingredients. First, warm ocean water, 26.5 degrees Celsius or hotter, evaporates, fueling the storm. Second, a moist atmosphere lets that vapor rise, condense, and release heat, forming dense clouds. Third, a low-pressure area pulls air in. Fourth, the Coriolis effect from Earth's spin kicks in the rotation, but not near the equator. Fifth, low wind shear keeps it stable by preventing winds from tearing it apart. Step 1. Tropical cyclones form over oceans between the tropics of Cancer and Capricorn. Warm water, above 26.5 degrees Celsius, evaporates, sending moist air upward, lowering the pressure at the surface. Step 2. That air rises, cools, and condenses at higher altitudes, releasing latent heat. This heat fuels dense cloud formation and deepens the low-pressure zone. Step 3. Nearby cooler areas have denser, high-pressure air. Air flows from these high-pressure zones into the warm, low-pressure area. Step 4. The Coriolis effect bends this inflow, spinning the system into a low-pressure eye, a calm center, surrounded by a stormy eye wall with the fiercest winds and rain. Step 5. If warm water and low wind shear persist, it grows into a full-blown cyclone, winds roaring and rain pouring. What's the Coriolis effect? It's the apparent deflection of moving air or water due to Earth's rotation. Not a real force, but an effect we see because Earth spins. The planet rotates west to east once every 24 hours. The equator zips along at 1,670 kilometers per hour, while the poles barely move. As air moves across this spinning surface, it curves, right in the northern hemisphere, left in the southern. In cyclones, air rushes into a low-pressure center. In the southern hemisphere, like with Cyclone Alfred, it deflects left, spinning clockwise. In the north, it spins counterclockwise. Why no cyclones at the equator? There, the speed difference is tiny, so there's no deflection to start the spin. Cyclones need at least 5 degrees latitude to form. How do cyclones move and fade? Once spinning starts, upper-level winds, like trade winds or jet streams, steer the cyclone across the ocean as it strengthens. Speed and path vary. It thrives on warm, moist air from the sea. When it hits dry land, that fuel runs out and friction slows it down. So, it unloads its wind and rain, then dissipates. How did Cyclone Alfred form? In February 2025, the Coral Sea east of Queensland hit 26.5 to 32 degrees Celsius, perfect for cyclone brewing. By February 20th, a tropical disturbance and the Coriolis effect sparked a low-pressure system, spinning clockwise in the southern hemisphere. Alfred matured over 2 weeks, crossed the Coral Sea, and slammed southeast Queensland and northern New South Wales in mid-March, unleashing wind and rain before fading over land. That's how cyclones, like Alfred, form, a wild dance of heat, air, and spin. Want more science? Like, subscribe, and tell me your ideas below.